Welcome to another episode of Between Two Vulns, where I am on drugs right now. I'm on a hefty dose of painkillers, so this is going to be an interesting episode. Dan, nice to be here again, isn't it?
Well, you should probably explain why.
Oh yeah, sorry, I got surgery. That's probably why. So my mouth looks really bad right now. But yeah, so I'm on drugs. Dan, what's going on? What's going on in the world of AI? We're going to be talking about the news.
Yep.
There's been some bombshell reporting. Well, I don't know about bombshell reporting, but that might be a little bit too much. But there's some really actually interesting advancements in AI recently, right? I think the first thing that we're going to talk about is LLMs plateauing, right?
Yes.
Because that's a big deal.
So a whole bunch of the top people in the sphere, in the space, have said that they're now seeing limited gains from the pre-training on larger and larger pieces of data and compute power. So they're seeing a plateau in LLM's performance as they scale up the data and the compute. And there's been a few people that have been saying this is going to happen for a while. Yann LeCun is one of the common voices that says that LLMs are not the path to artificial general intelligence.
Yes.
And so, he's claiming victory right now, saying, aha, I was right.
Yeah.
Maybe he is right, maybe he's not, we don't know. I'm not as smart as him, so I won't form an opinion. But it does seem to be a consensus.
Yes.
From Ilya Sutskever to Jeffrey Hinton and stuff.
And a bunch of, I mean, it was sort of known about for a while, I think. Like there was some talk from a lot of people who actually know a lot about LLMs and their architecture and like how they actually work, that we're going to hit an inflection point where they're just going to plateau in terms of like actual capabilities.
Right.
But the thing is, like as we were talking about even before, like that doesn't necessarily mean it's bad, because it's just going to get more efficient.
I don't think we're entering an AI winter.
Yeah, exactly.
I think that there's just going to be other ways of scaling this up. So we know that like the LLM models themselves are becoming more energy efficient. They're becoming more efficient with the data that they're using in order to train for effectiveness of output. So there's it's a very multivariate, multidimensional problem. It's not just it doesn't end at LLMs are plateauing, therefore the AI hype cycle is completely derailed and everything's going to go away.
Yeah. And it's just going to get more efficient too. So like it's going to get cheaper.
And there's other strategies too, like GPT-o1 has the inference time train trade-off, where you can just tell it to just think about its own thoughts for longer and longer periods of time to get better output. So it's a really interesting thing that it is plateauing right now. Sutskever is quoted as saying the 2010s were the age of scaling. Now we're back in the age of wonder and discovery again. Everyone is looking for the next big thing. Yeah. Scaling the right way matters more now than ever. Yeah. So he's saying that we just need to improve the processes, and maybe that'll bust through the plateau.
And it might be that also that we use a completely different architecture from transformers. Yeah. Because there's a lot of other architectures out there for LLMs, like Mamba. I don't know anything about like how that actually works in the front, in like the back end there, but there's apparently a lot of other architectures that are possibility in terms of potential applications, in terms of making them LLMs.
I have a big feeling like New York Times and headlines are going to be like, it's all over. It's all done. I really don't think that's going to be the case.
Not. If anything, it'll be the reverse, because now that it's going to get more efficient and cheaper, organizations might adopt LLMs a lot more.
Right. And this was something we were talking about before at dinner, was the LLMs today, they're incredibly powerful. Yeah. The problem isn't really that we need to improve the LLMs of today. The problem is we need the engineering application to put the LLMs into use in places that, like automation, for instance. Putting the LLMs into the right place in an organization to save time and money is like the main problem right now for why we haven't seen LLM adoption all over the place. You have to apply it. It's kind of like the laser from the 1970s. It's like it was a problem, it was a solution without a problem, and now lasers are everywhere.
Yeah, exactly.
Everything you touch is
that actually leads into a good segue into the other piece of news, which is Microsoft apparently is rumored to have infinite memory,
near infinite memory
in their LLMs. And this goes to the like LLMs plateauing sort of conversation, because like might plateau but might make it more efficient at the same time.
Right. If context windows are increasing, then do we care that much if the pre-training is plateauing?
Exactly. Like if it has infinite context window, that would be like a game changer for sure. Yeah. Like at that point,
they've been teasing this for a while now. But now the CEO came out and said that they have prototypes that are near infinite memory, which I'm reading into that to say near infinite context windows. Google has claimed similar things. I mean, Google Gemini has 2 million tokens of context window. We've seen this exponential rise in this. So other aspects of LLMs are still pushing forward quite quickly at an exponential rate, other than just the pre-training efficacy.
Yeah, exactly. And it would be interesting to see like how that, like if that actually comes out, like how that affects like the stuff that we did with VulnHuntr, right? Like I'd be interested to see like if it's as accurate as like if I give it like an entire GitHub repository of code, right?
Right.
I wonder if it'll be as accurate as VulnHuntr, like right now, right? Instead of giving it like pieces, like specific targeted pieces of information as opposed to everything.
Speaking
like
of which,
that'd be interesting.
VulnHuntr. We released VulnHuntr.
Oh yeah, that's right. Yeah, this is we never addressed this, but
VulnHuntr is our cool little research project that is a static code analyzer for Python. You can find it on GitHub at protectAI/VulnHuntr.
Yes.
It's crossed over 1,000 stars. Pretty excited about that.
That is pretty exciting. Yes.
Basically, what it does is it uses an LLM to analyze call chains inside of Python code to find multi-step complex vulnerabilities that traditional static code analyzers can't find. So like Sneak and semgrep and varicode, all these kind of analyzers, they generally just read through the strings and like regex for an expression like eval parentheses, and they go, hey, you might have a bug here in this eval, but they can't trace where the input is coming from throughout the code base and then trace it all the way down until it hits eval and tell you for sure there's a bug or not.
Yeah. Yeah. So we released that. It got a decent amount of attention, almost 1,000 stars.
And then a month later, Google released their first
their first
autonomous LLM 0 day.
Yeah.
So we claim the title, rightly or wrongly, I'm pretty sure it's right, of world's first autonomously found 0 days. We got 14 0 days using VulnHuntr.
Yeah.
Never been discovered vulnerabilities.
And just to be clear, like VulnHuntr is like, it's not finding, like the Google's thing was finding memory corruption style vulnerabilities, where like VulnHuntr finds like web application stuff, which is more suited to, or like what huntr.com reports are, what they do, and they're mostly web application stuff, OWASP top 10 kind of stuff. So that's basically, it's really exciting.
The keys to VulnHuntr though was to narrow the task dramatically. So to your question of, is it going to work as well with the 2 million context window? Can you just dump all the code in there and say, can you find me 0 days? I suspect, well, I know, as of today, right now, that doesn't work well at all because I've experimented with this. You need to have very narrow code chain calls that you give to the LLM without extraneous code, and then a very, very, very specific prompt.
Yes.
That was key. So VulnHuntr actually uses 7 different prompts. For cross-site scripting, RCE.
There's like I think it's more because there's a summary prompt, and then there's like vulnerability specific prompts.
Right.
It's like 9 or.
But the vulnerability specific prompts, it does 7 different specific vulnerabilities.
Yeah, exactly.
And what we found was you have to break out those instruction prompts specific to vulnerability. You can't just ask it, hey, even if you give it a very narrow, limited window of code, you can't just ask it, go find me vulnerabilities. It doesn't work well at all. But when you tell it, can you find me an XSS in this? Can you find me an RCE in this? It works astonishingly well.
Yeah.
Astonishingly well.
And with that, I think that's the news segment. And now we're going to be handing it over to Ethan.
Yes.
Who's going to talk about huntr transitioning over to model file vulnerabilities?
Yes, we are adding a new category of attacks into huntr called model file vulnerabilities. And just to clarify, whenever you think of like AI security, you can kind of group this into 3 categories. You have the supply chain, which is all the open source libraries used to test, train, store models like MLflow or NumPy. And then you have the model file itself, which can execute code. A lot of people, I think so.
NumPy?
Yeah.
I always said NumPy in my head.
Oh yeah. Maybe it is NumPy.
NumPy?
That makes sense too.
Sounds really weird.
But then you have the model file itself, which can execute code, and many people don't realize that. So that's where we're opening up a new branch in huntr for new vulnerabilities that are very unique to the ones that we had before. Before it was a lot of web application vulnerabilities, and now we're going to have a file format vulnerabilities.
And the bounty is double, so
you can make a lot of money.
A lot of dollar bills there. And with that, we're going to transition over to Ethan. Take it away.
Hi Hunters, my name is Ethan Silvas, and today we're going to go over our new bounty program, the Model Format Vulnerability Program. So Huntr is going to kind of make more of a shift towards these compared to our normal open source vulnerabilities. So I thought we might go over kind of an introduction to the program and kind of get an idea of what we're looking for. So what is a model format vulnerability? So we can see here, a model format vulnerability refers to a security flaw that arises from the way an AI ML model is stored or serialized in a specific file format. So essentially what we're looking for is when some sort of payload can be stored inside of a machine learning model, and that payload will get executed typically when you load in the model with some sort of machine learning library. But there are also other attacks that happen when the model is actually used or run. So these kinds of vulnerabilities. Right now we know about 2 broad categories of what model format vulnerabilities are. So one is deserialization, which is kind of more of when you actually put a payload inside of a model file and it gets loaded with some sort of library like TensorFlow, for example. And backdoors are a little bit more hidden. Those are ones that you typically get executed when you actually run the model, and they actually run in the background of the model. So usually a backdoor payload gets executed behind the scenes. The model itself will kind of run normally like a normal model, but something's going on in the background, so that like maybe a payload gets executed, or like data in the model itself gets modified without the user knowing. Just to be clear, those are 2 broad categories, and they're also vulnerabilities that we know about now. So model format vulnerabilities and model security in general is a very new field. Even here at Protect AI, we're not totally sure what all of the potential vulnerabilities are out there, since it's such a new field. So if you find some other types of vulnerabilities, other than ones that we've seen, feel free to send it to us. We'll take a look at it and basically try to think of anything that puts a user or somebody using one of these models at danger or at risk, or their machine potentially. Yeah, send it to us. So a couple other things to know. So first off, since these are brand new vulnerabilities in our new program, we want to focus on them. The potential for a bounty on one of these, if it's not in a pickle file, you could earn up to $3,000 if you find a critical vulnerability. So that's nice to know. Since it's a beta program, and again, we not really sure how to score some of these in terms of like CVSS scores. We're not giving out CVEs just yet. We might think about it in the future. We will also review them within 45 days, like our normal rules, maybe even potentially faster. So the scope, all model formats, and you can almost think of it like format model file extensions. Those are in scope. If we don't have any in our list, which I'll go over in a sec, please let us know and send it to us anyway. All hunters can participate. It's not a private program. And yeah, and I'll go over the resources in a sec, but yeah, so you can see here, this is how you would submit a vulnerability. You can look at all of our targets, which are essentially either machine learning libraries or again, the files themselves. So we're specifically looking at things like if you want to test against llama file, you would try to find a vulnerability in a llama file actual file and put it into it, and then see if our scanner detects it. So let's actually look at some of the vulnerabilities that we already know about. So if you go to protectai.com/insights and you go over to knowledge base, you can see these kinds of different attacks that we already know about, like again, the deserialization threats and the backdoors and stuff. You can look at some examples that our scanners already look for. So I would read up on these, and we are going to go over a very, very simple example. Because there is notoriously an issue with Python's pickle module, which has a deserialization vulnerability in it that you can inject an RC payload into it, and then whenever you load that pickle file, it executes that payload. So one of our targets, joblib, right here, this uses pickle on the back, behind the scenes. So it also has that deserialization vulnerability. So one thing to know that when you're looking for these types of vulnerabilities, you want to go through to our target list here and look through all of these libraries and look up how do you actually use the library. Specifically, how do you load a model file and how do you run a model file. And then once you kind of know what you're doing and how to use it, you can start to think about how or what actually happens to the model file and the logic that you put into it when you either load it or when you run the model itself. So when we do that with joblib, we can see that, okay, so first off, let's look at a simple example. This is how you load a joblib file with joblib, right? And then we can now take a look at what actually happens when you load a model file like that. And of course, this one actually gives you a giant warning saying joblib.load actually uses pickle behind the scenes. Pickle has the notorious deserialization vulnerability in it. And so we can actually test it with something that's very nice and handy for these machine learning types of vulnerabilities, is Google Colab, because Google Colab, it gives you resources that you might not actually have. A lot of these machine learning libraries require something like a GPU, for example, and they actually come preloaded with a lot of machine learning libraries. So it just makes it easy. So we'll go through this simple joblib example. So again, just importing joblib, going through the documentation, looking at how to use it. And yeah, this is the pickle deserialization vulnerability I'm talking about. Pretty simple. You just inject an RCE payload into this reduce method, create a class of it, and the idea is that when an instance of this class gets deserialized with pickle, it actually executes whatever payload you put into here. So again, joblib is using pickle behind the scenes. So this dump method, this is how you create a malicious joblib file. You inject an instance of your malicious class into it, and of course, to simulate the victim behavior here. So again, the victim is essentially just anybody who's trying to use a model. And when you actually load this model, give it a sec here, you can see that the payload, the RCE payload in this case, which is just to create a malicious Python file, it actually gets executed. You can see it got created here in my sidebar. And so yeah, that's kind of the gist of it. This is a very simple example, I know, but again, the idea is you're injecting a payload into a model file, and when a victim loads that model file or potentially runs it, your payload gets executed. So now that you think that you might have a vulnerability, how do you know if it's valid? So if you go to Protect AI's model scan repository on GitHub, we already have a scanner that detects these kinds of vulnerabilities, and you can actually load this public version yourself. It's very easy to install. You just pip install it, and using it, you can create your malicious payload and actually just run model scan like you see here to see if it detects it. So again, this is our public version, so it's not the same as our proprietary version. So it's going to be a little bit less, good. It's not going to detect everything, but once you have a payload that you think is like really good, it passes our public version of model scan, you can actually go into our Hugging Face partnership that we did, and this is the kind of private version of that model scan. And you can see here, if you upload a public model to Hugging Face, you can see that our scanner actually scans it, and this, for example, this isn't malicious, so you can see there's no issue. But if your payload in your model passes model scan, and if you upload it to Hugging Face and there's no issue, then you might actually have a vulnerable bypass with the model file that passes our scanners. And yeah, that should be a vulnerability. We'll assess it if there's actually impact to the person that's actually loading the model file. But other than that, yeah, that's kind of how you find model format vulnerabilities. And yeah, hopefully this gives you an idea of how to look for them and what we're looking for and those kinds of things. But yeah, feel free to send us anything that you think puts these machine learning engineers in danger when they're loading these models. And yeah, we'll look forward to reviewing your reports. Bye.
All right, thanks, Ethan. I hope that was wonderfully informative to everyone.
Sure it was.
And it's probably going to make a lot of people a lot of money because those bounties are pretty crazy.
Oh.
So with that, we will see you next time.
Yes. Remember to smash that button and use the Claude's OpenAI computer use API to smash the subscribe button on the. You can even do that now. Why press a button when you can make an LLM do it for you?
Yeah.